Everything you see around you, the ground beneath your feet, the air you breathe, the moon, the sun, every star in the sky, all of it, every single bit of visible matter makes up just 5% of the entire universe. Think about that for a second. Only 5%. So, what about the other 95%? Well, most of it is a complete mystery. It's invisible. It's everywhere. And without it, our universe, and even our own existence, would be impossible. We call it dark matter. But what if, just for a moment, we could actually see it? What would the universe truly look like? Imagine yourself on a clear night, far away from the city lights. You look up and see a breathtaking canvas of stars scattered across an endless expanse of black. It's beautiful, but it is an illusion. What you can't see is the hidden architecture, the invisible web connecting everything. This is the domain of dark matter. It's not like anything we know. It's not matter in the traditional sense. It doesn't emit light. It doesn't reflect it. And it doesn't block it. You can't see it with any telescope, no matter how powerful. It's the invisible skeleton holding the entire cosmos together. Here's a mind-bending fact. When astronomers look at galaxies, like our own Milky Way, they see them spinning at incredible speeds. In fact, they re-spinning so fast that the gravity from all their visible stars and gas should unbe nearly enough to hold them together. By all conventional logic, they should have flown apart billions of years ago, their stars scattering into the void like dust in the wind. But they don't. They remain perfectly intact, gracefully pirouetting through space. Why? Because something else is there. Something massive, unseen, and incredibly powerful, providing the extra gravitational glue needed to keep them from disintegrating. That something is dark matter. It forms a vast, invisible halo around galaxies, holding them in its gravitational embrace. Without it, the Milky Way would have been torn to shreds long ago. So, how did we discover something we can't even see? Scientists found it not by looking, but by doing the math. Back in the 1930s, an astronomer named Fritz Zwicky was studying a cluster of galaxies and noticed they were moving far too quickly. The math just didn't add up. There had to be more mass, much more, than what he could see. He called it dunkle materie, or dark materie. For decades, it was a fascinating but unproven idea. But as our observations got better, the evidence became undeniable. We see its effects everywhere. We see it in the way light from distant galaxies gets bent as it passes through. Space a phenomena called gravitational lensing. The light is being warped by the gravity of something we can't see. Today, supercomputer simulations have given us a breathtaking glimpse into what this hidden universe might look like. They show that dark matter isn't just randomly scattered. It forms a colossal structure known as the cosmic web. Imagine a vast, intricate network of invisible filaments and nodes stretching across billions of light, connecting massive clusters of galaxies. If we could somehow make this web visible, space would no longer look like an empty void. It would be transformed into a shimmering, glowing tapestry of cosmic threads. The galaxies we see would be like bright beads of light hanging at the intersections of this immense, invisible structure. And we, on our tiny planet, are woven into this web, drifting through an unseen cosmic ocean. This brings us to the billion-dollar question. What is this stuff actually made of? The honest, and slightly frustrating, answer is, we don't know. This is one of the biggest mysteries in all of science. The leading theory for years was that dark matter consists of particles called WIMPs, which stands for weakly interacting massive particles. These are hypothetical particles that are heavy but barely interact with normal matter, except through gravity. They would be all around us, passing through the Earth, and even through our bodies, by the billions every second, without us ever noticing. To hunt for these elusive particles, scientists have built incredibly sensitive detectors deep underground, in places like old mine shafts, shielded by kilometers of rock to block out cosmic rays and other noise. The hope is that, just once in a while, a WIMP will randomly bump into an atom in the detector and create a tiny, detectable signal. But so far, after years of searching, silence, nothing. This has led scientists to explore other possibilities. Maybe dark matter is made of axions, Another hypothetical particle that's incredibly lightweight and even less interactive than WIMPs. Odperabsit. Something far stranger. Something that hints at a whole new realm of physics beyond our current understanding. Dark matter doesn't seem to care about light, or electromagnetism, or the forces that build atoms. It seems to listen to only one fundamental force: gravity. So let's go back to our thought experiment. Let's imagine, for just one moment, you were given a pair of dark matter glasses. You put them on, and suddenly, you can see it. What would happen? The night sky would erupt. It would transform from a collection of discrete points of light into a living, breathing cosmic map. Every galaxy would suddenly reveal its true form: a small, bright core of stars embedded within a colossal, shimmering halo of dark matter. A ghostly sphere swirling with invisible substance, dwarfing the galaxy itself. Our own Milky Way would no longer be just a band of light across the sky. It would be a vast, luminous cloud enveloping us completely. And it wouldn't just be out in deep space. Even here on Earth, the world would look different. The air itself would seem to have a faint, ethereal shimmer, a constant, gentle rain of particles passing through you, me, and every object around us. You'd see dense rivers of it flowing through the core of the Earth and the Sun, drawn in by their gravity. Reality itself would take on a new dimension, revealing the invisible mist of gravity that connects every star, every planet, and every atom into one single, unified cosmic web. You would finally see the true, underlying structure of the universe. There's a deeper, more profound truth here. The mystery of dark matter reminds us that the universe is UN-built only from the things we can perceive with our senses. Think about the most powerful forces that shape our lives. Gravity, which holds us to the Earth. Time, which pulls us relentlessly forward. Even consciousness, the very thoughts inside your head, all of them are invisible, yet they are undeniably real. Dark matter isn't just some passive filler material occupying the empty spaces. It is a fundamental, active architect of the cosmos. It was there from the very beginning, just after the Big Bang. It began to clump together under its own gravity, forming invisible seeds. Over millions of years, these seeds attracted normal matter, providing the gravitational scaffolding upon which the first galaxies, stars, and eventually planets could form. Without dark matter, those initial seeds would never have existed. The universe would be a thin, uniform soup of gas, with no galaxies, no stars, no planets, and no us. And yet, after all this time, we are still blind to 95% of our own universe. Every new telescope we build, every particle collider we power up, every sensitive detector we bury deep in the Earth, we are all, in a sense, chasing a ghost. Maybe one day, we'll finally have that breakthrough moment and detect a dark matter particle. Or maybe the answer will be something we never could have imagined. But here's the beautiful truth. The invisible is not the same as the impossible. Just because we can't see something doesn't mean it isn't there. The universe is 95% mystery. And that isn't terrifying, that's exhilarating. It means the age of discovery is far from over. It means there is still so much left to find. And maybe, just maybe, someday soon, we'll finally open our eyes and see the invisible universe all around us. What we can't see it might just be what holds everything together. Thanks so much for exploring this cosmic mystery with us today. If you enjoyed this journey into the unknown, don't forget to hit that like button and subscribe for more deep dives into the universe. We'll see you in the next one.